Hi, geometry scholars. Here we are in section 6.4. Remember, we went from 6.1 to 6.4 because we're skipping over those 2 and 3. The new section is called the triangle midsegment theorem. And we already actually alluded to this when we did the chapter opener. So really, the objective is that you'll be able to use midsegments of triangles in the coordinate plane, as well as using the triangle midsegment theorem to find distances. So there's a little bit of algebra involved. The core vocabulary is the midsegment of a triangle. And the previous words you should all remember are midpoint, parallel, slope, and we did not do coordinate proof, so that one shouldn't matter. So we'll just go ahead and move on to the theorems and examples using the midsegment of a triangle. So the midsegment of a triangle is the segment that joins midpoints, okay, of two sides. So there's 3 of them because every triangle has 3 midsegments, and that forms the inside midsegment triangle, which, as you can see, is MNP. Again, the midsegment triangle goes from the midpoint of each side to the midpoint of the next side. So the midpoints of triangle ABC at the right are MP, MN, and NP. The midsegment triangle, therefore, is MNP. So here's an example of how we can solve for a midsegment by using the coordinate plane.
In triangle JKL, show that midsegment MN is parallel to segment JL and that MN is equal to 1/2 JL. Solution. In the figure, midsegment MN can be called the midsegment opposite segment JL. Step 1. Find the coordinates of M and N by finding the midpoints of segment JK and segment KL. The coordinates of the midpoint M are -6 plus -2, all divided by 2, 1 plus 5, all divided by 2, which is equal to -8 divided by 2, 6 divided by 2. Simplify, and the midpoint M is -4, 3. The coordinates of midpoint N are -2 plus 2, all divided by 2, 5 plus -1, all divided by 2, which is equal to 0 divided by 2, 4 divided by 2. Simplify, and the midpoint N is 0, 2. Step 2. Find and compare the slopes of segment MN and segment JL. The slope of segment MN is equal to the quantity 2 minus 3 divided by the quantity 0 minus -4, which is equal to -1/4. The slope of segment JL is equal to the quantity -1 minus 1 divided by the quantity 2 minus -6, which is equal to -2/8, which equals -1/4. Because the slopes are the same, segment MN is parallel to segment JL. Step 3. Find and compare the lengths of segment MN and segment JL. To find the lengths, use the distance formula. MN is equal to the square root of the quantity 0 minus -4 squared plus the quantity 2 minus 3 squared. Simplify, and this is equal to the square root of the quantity 16 plus 1, which is equal to the square root of 17. JL is equal to the square root of the quantity 2 minus -6 squared plus the quantity -1 minus 1 squared. Simplify, and this is equal to the square root of the quantity 64 plus 4, which is equal to the square root of 68, which is equal to 2 times the square root of 17. Because the square root of 17 is 1/2 times the quantity 2 times the square root of 17, MN is equal to 1/2 JL.
So for each one of these parts, we're going to review the concept of slope and distance formula. It's also in our notes. Do that in class. Now we do have a theorem that says the segment connecting the midpoints of two sides of a triangle is parallel to the third side, and it's half as long as that side. So if D is the midpoint of BA and E is the midpoint of BC and DE is connected, then not only is it parallel to AC, but it's also half the length. There is a proof. It's question 3, example 22. For right now, we're just going to use it to solve those problems. We're not going to actually go over the proof, but here is an example of how you would do it.
Write a coordinate proof of the triangle midsegment theorem for one midsegment. Given segment DE is a midsegment of triangle OBC, prove segment DE is parallel to segment OC and DE is equal to 1/2 OC. Solution. Step 1. Place triangle OBC in a coordinate plane and assign coordinates. Place vertex O at the origin, so the coordinates of vertex O are 0, 0. When assigning coordinates to the other two vertices, try to choose coordinates that make some of the computations easier. In this example, you can avoid fractions by using 2p, 2q, and 2r. Because you are finding midpoints, use 2p, 2q, and 2r. Let the coordinates of vertex C be 2p, 0, and the coordinates of vertex B can be 2q, 2r. Sketch midsegment DE. Then find the coordinates of D and E. The coordinates of midpoint D are the quantity 2q plus 0 divided by 2, the quantity 2r plus 0 divided by 2. Simplify, and this is equal to qr. The coordinates of the midpoint E are the quantity 2q plus 2p divided by 2, the quantity 2r plus 0 divided by 2. Simplify, and this is equal to q plus p r. Step 2. Prove segment DE is parallel to segment OC. Parallel lines have the same slope, so find the slope of each line segment. The y-coordinates of D and E are the same, so segment DE has a slope of 0. Segment OC is on the x-axis, so its slope is also 0. Because their slopes are the same, segment DE is parallel to segment OC. Step 3. Prove DE is equal to 1/2 OC. Use the ruler postulate to find DE and OC. DE is equal to the absolute value of the quantity Q plus P minus Q, which equals P. OC is equal to the absolute value of the quantity 2P minus 0, which is equal to 2P. Because P is equal to 1/2 times the quantity 2P, and DE is equal to P, and OC is equal to 2P, then DE is equal to 1/2 OC.
Now, I need you all to understand that we did not do coordinate proofs in our previous section. So this may or may not make sense to you. If it does, fantastic. If it doesn't, don't worry about it too much. As long as you can follow along, that's all I need you to get out of it right now. I won't ask you to do this on your own, but you should be able to follow the concepts to show that we can prove that DE is half of 1/2 OC. Okay. But here is an example where we're going to actually use the midsegment theorem, and this is in our class notes. I'm going to go ahead and start now.
Triangles are used for strength in roof trusses. In the diagram, segment UV and segment VW are midsegments of triangle RST. Find UV and RS. Solution. To find UV, locate segment UV in the diagram. You are told segment UV is a midsegment. So in the diagram, you can see segment UV is the midsegment opposite segment RT. By the triangle midsegment theorem, UV is equal to 1/2 times RT. In the diagram, you can see RT is 90 inches. Substitute 90 inches for RT, which equals 1/2 times 90 inches. Multiply, and this is equal to 45 inches. To find RS, locate segment RS in the diagram. You were told segment VW is a midsegment of triangle RST. In the diagram, you can see segment VW is the midsegment opposite segment RS. So by the triangle midsegment theorem,
VW is equal to 1/2 times RS, or
RS is equal to 2 times VW. In the diagram, you are given the length VW is 57 inches. So substitute 57 inches for VW, and this is equal to 2 times 57 inches. Multiply, and this is equal to 114 inches. So the length of segment UV is 45 inches, and the length of segment RS is 114 inches.
And that's specifically how we're going to use that. So keep in mind the triangle midsegment theorem. There's another example, and this is a kaleidoscope.
In the kaleidoscope image, segment AE is congruent to segment BE, and segment AD is congruent to segment CD. Show that segment CB is parallel to segment DE. Solution. You are given segment AE is congruent to segment BE, and segment AD is congruent to segment CD. Because segment AE is congruent to segment BE, and segment AD is congruent to segment CD, E is the midpoint of segment AB, and D is the midpoint of segment AC by the definition of midpoint. Then segment DE is a midsegment of triangle ABC by definition of midsegment. And segment CB is parallel to segment DE by the triangle midsegment theorem.
That's all you got to do. Now, this problem for modeling, we're going to do together under the camera. So I'm going to end or skip that one for now. And then we're going to go on to monitoring. This is where the problems start. I believe I'm only assigning you like 8 problems. They're a little more involved, 8 or 10, I can't remember. But if you just follow that one theorem, okay, get that one idea down pat, you'll do just fine. And then again, we'll do some more examples under the camera.